Hello everyone, welcome back to this episode of Data Talk. On this episode, I'm going to continue the introduction of data visualization. So before I go to the notebook, let me show you just two websites which we can see the different user case of data visualization. The first one is Ourworldindata.org. You can find a wide range of world data in this website. For example, now I'm seeing the display of explore data on metals and minerals. You can see there is a line graph, line chart, and you can also play time lapse. It's very well designed and a very clear display of the data. And you can also choose the heat map on geolocations, see the original tables, choose the data series that you want to visualize, and so on. And there are many other options where you can explore different data display. Data visualization. The second one is a neural network playground. This is developed by TensorFlow. I really encourage you to try it because here you can see multiple elements. You can see the visual design of the training process of a neural network. You can also see the visual display of the output. Now, as you can see, I have run this page for like one night, more or less 8 to 9 hours until now, and now it has run over 100,000 epoch. So in here, you can both try to change the different hyperparameter, different feature, different hidden layers, different neuron design of a neural network, and see how it goes to the final output. You can also see here the test loss and training loss very clearly. So these two websites can both show you how important it is to visualize data, because the more visual we get, the more direct sense we can have about either training a model or the data distribution or the trend of an event or a variable. So now let's go back to the notebook. So today I'm going to share with you some of the use case utilizing Seaborn, another package from Python. I have listed some examples from beginner level to advanced level. Of course, please bear in mind, this is not a very comprehensive introduction. So which means that the separation of the level is my personal opinion, and there are many more use cases that you can expand from here. So I wish this would be helpful for you. First of all, let's see, before we visualize any data, it's better that we see the data, okay, to print the data head. So this tips dataset is actually inside of the Seaborn package, okay. For utilizing any package, we first import and then do the preliminary step to visualize the data frame or to visualize other characteristic. You can also use different function like description and so on. So now we understand that we are seeing this the bill, or we can say the tip per bill dataset. And we can see there are many variables here. We can see the total bill number, the tip number, sex, smoker or not, which day of that bill, the time is dinner time or lunch time, and there is also size. So the size variable, I think, is about the table size for 2 persons or 3 persons. And one of the simple plots is scatter plot. You can see the relationship between the total bill and the tip. So basically, you can see it goes from the lower left to the upper right. This is a quite positive relationship. When you pay a higher bill, your tip number goes up. But it is also very important to note that the scale of the different axes are different. Here, we see another type of visualization is utilizing the bar plots and box plots. So in here, in this bar plot, I put the x-axis as day, which day was the bill paid, and also the tip value as y-axis. As you can see, we can see the average value of each day. The tip value could reach to the average tip value could reach to which level as the edge of this bar, and also we can see a fluctuation range, okay, of this value. It is very common also in the case when we evaluate a large language model. You can see different reports that when we evaluate, for example, if this one is about the precision of the math task. Okay, the precision level, the average at which level, and fluctuate to which range. So it's quite useful. And more precisely, that black line is the error bar. It actually is a 95% confidence interval, which you can use it to see the distribution of the data in a very quick way, in addition to the bar plot. And I add a note here. You can check in detail how you can utilize it. And especially when you see if the distribution are not overlapping between the different categories, which means that they are statistically different if they are not overlapping a lot. If they overlap, which means the distribution are very similar from each other. Now let's take a look at the box plot. Okay, the box plot is also very important for us to visualize the distribution of the data. So you can see for each day the tip value range from which number to another number. And if this one is not very direct, or you still have doubt to interpret it, for example, you don't know about the quartile and don't know about outliers, another way to visualize it is to put the box plot horizontally and the histogram of this series next to it. And you just mark the Q1, Q2, and Q3. So you can see the general distribution of the data. Okay, so for each day is different. Whenever you see there are dots, which means there are significant outliers, okay, less outliers, almost no outliers. You can also see in Seaborn how they put the outliers. Okay, so you can see the dots represent tips that fall outside the range of the whiskers. So you don't see it in every type of distribution. Only some distribution which we have significant outlier defined by Seaborn, we are going to see these dots. Now let's check the pair plots. The pair plots, you can see the pairwise distribution. For example, I want to see the relationship between the size and total bill. I can see this one. So I can see roughly their relationship, right? And in here, inside of it, whenever you see the tips overlap with tips, like here in the middle of the graph, you can see the distribution histogram of tip. So it's a range of its value and the distribution between of the different value in a histogram style. And here we can see we can also show the heat map of the data, but pay attention, heat map is only available for numerical data, so which means that whenever we have categorical data here, we cannot visualize it. So as you can see here, I get an error. So in order to solve the error, first of all, I inspected the data frame again. I see there are many categorical data like sex, smoker. There are many ways to solve the issue, or we can say to encode the categorical data. As you can see here, if we use pandas, we just transform it to dummies, it will be like this. So for each categorical variable, for example, is male or no, yes or no, is true or false. For sex female, true or false, and so on. And for the date variable, it actually separated to 4 because we have 4 types of the date choice. So if Sunday is true, the others are false. Okay, this is a quick way to transfer categorical data to the dummy variable where true is 1, false is 0. And we can also see the lunchtime and dinner time as dummy variable and encoded with true or false. There are also other ways to encode the dummy variable or categorical variable, and you may choose and try it. So basically, this kind of coding is also called a one-hot encode. And after this transformation, now I can display the heat map. As you can see, we can see this correlation table. One variable is correlated to another variable at which level. More positive, which means that they are more positively correlated or negatively correlated. Let's just take one example. So basically like this one, we see time lunch, okay, and also the day Thursday, and it is very positively correlated 0.92, so which means that on that day most people would choose to have lunch, okay, in this distribution. And you can also examine the different one. For example, if in this group, if female or male is more prone to be a smoker, and so on. We can see the distribution of data, relationship of the data, and also to interpret it to see some patterns. Then you can also see here, I print out the correlation table. You can see only the numerical display of this data. And if you do not want to see the categorical variable in this correlation table because you think it's less useful, you can just delete these features and you only see the numerical variable, how they correlate with each other. So basically we can see here almost all the variables are positively correlated with each other. Then we see here there is another type of graph where we can display, and here we can see the comparison of different category in a scatter plot pattern. As you can see here, we have sex as male, time as lunch, then male in dinner time, and then we can see that the tips which a male would give during dinner time are more scattered across a longer range, and we can see there are more generous tips happens from time to time, not very often, but there are some outliers very easily to be identified. And we can also compare horizontally, so we see the sex as male or female, and both at lunchtime. So their tipping behavior are quite similar. And we can see female actually has a tipping behavior more consistent, either is lunch or dinner. But if we compare the female with the male at dinner time, I would say the female tipping behavior is relatively more conservative. They tip less because you do not see outlier, or we can say they don't pay the tips very distant from their average behavior. So you can see a lot of information here. In this type of grid, you can compare them in different ways. Then we can see here there is a violin plot. This kind of plot, you can see the distribution of data across different categories, which is also very useful. It's more useful when you can identify where most of the data is not distributed around the mean. So in that case, you need to pay great attention. So which means that the distribution are at the two sides of the total distribution, not in a bell shape. So a bell shape usually is close to the normal distribution, as you know, where we have the mode, mean, different parameters close to each other. But if they are very distant from each other, you may need to take a different perspective and examine the data differently. Okay, so just in conclusion, I think the Seaborn is a very useful tool. You can explore more options in the official documents and try your use case. And as I said before, data visualization is very important. So please keep exploring and try different tools to visualize your data. I wish this episode is useful for you. If you have any question, feel free to leave a comment. If you like my videos, please subscribe and see you next time. Bye bye.